Very good morning. I am Dr. Senthil Kumar, Associate Professor in the Department of Agriculture Engineering, SNS College of Technology. Let me present the article topic Hyperspectral Remote Sensing of Vegetation. And to say about the hyperspectral vegetation, remote sensing of vegetation, it is a fast emerging a practical solution in modeling and mapping of vegetation. Recent research has demonstrated the advances in and merit of hyperspectral data in the range of applications, including quantifying the agriculture crops, modeling forest canopy, biochemical properties, detecting crop stress and diseases, mapping leaf chlorophyll content as it influences crop production, identifying plant affected by the contaminants like aseptic, arsenic, demonstrating sensitivity to plant nitrogen content, classifying vegetation species and types, etc. Disabled introduction, nearly this research on hyperspectral remote sensing was there for more than 40 years. Previously, it was mainly focused on the conditions of the agriculture crops. But now the thing is that this hyperspectral remote sensing are focused on the minerals. Now it is more concentrating about the location of the vegetation. This modeling and mapping of vegetation and agriculture crop using the ground-based platform-mounted airborne unmanned aerial vehicle mounted and space-bound hypersector remote sensing. The state of art in hypersector remote sensing of vegetation and agriculture shows significant enhancement over conventional remote sensing, leading to the improved and targeted modeling and mapping of specific agriculture characteristics such as biophysics and biochemical qualities. You can see the image for representing the hyperspectral remote sensing of vegetation, how it is connected with the satellite, and how we are getting the data on vegetation. You can see in this image. And to say about the study of vegetation, that's narrow band and agriculture crops, avoiding a large number of redundant data, that is near to 88%, and focusing and utilizing a non-redundant bands. This is near to 12%, which is helps in overcoming Hughes phenomena. The constituting specific hyperspectral vegetation indices, that is, we used to term it as HVI, obtaining the same or nearly same classification accuracy using the optimal 28 HNB as opposed to the full range of bands, increasing the computational speed and optimizing the resources in computing and analyzing. To say about the future of remote sensing, it is likely to involve regular and routine acquisition of hyperspectral data from which broadbands and simulated. This is a win-win situation provided data continuity for the past satellite and it at the same time providing the advanced spectral agricultural needs for increased understanding of global vegetation and agriculture. Hughes phenomena with the increased number of hyperspectral narrow bands of large number of samples, that is training pixels required to maintain minimum statistical confidence and functionality in hyperspectral data for classification powers grows exponentially, making it very difficult to address this issue adequately. Problem is known as Hughes phenomena and can be addressed by overcoming the data redundancy and through obtaining large number of training pixels of each class. And thank you for watching this article on hyperspectral remote sensing of vegetation. Thank you all.